In college algebra today, we graphed rational functions. So there are 6 steps to doing it, and step 1 is something that I haven't talked about yet. So let's briefly talk about it. It's something pretty simple, and it's more of a guide in what to expect when you graph it. So all it is plug in, or all you need to do to check for symmetry is plug in negative x. So if when you plug in negative x, you get f of x, meaning I plug in negative x, I do some simplifying, and I get the exact same function that I started with, then there is y-axis symmetry. If I plug in negative x, and I do all my simplifying, and every sign flips, that's what negative f of x means, every sign flips, then there is origin symmetry. And then if neither of those circumstances happen, then no symmetry. I mean, technically there could be a different type of symmetry, but we're just going to worry about those 2 types, y-axis and origin symmetry. Otherwise, everything else is pretty straightforward, things that we've talked about. For the sake of space, I'm going to start this one right here. Sorry that's not under the problem, but I want to try and fit all this stuff and see the steps all on one page. So I'm going to figure out if there's symmetry. So I plug in f of negative x, and I'm going to use parentheses. So negative x here, and negative x there. Do any simplifying that you can, and we end up with negative 2x, negative x minus 1. So ask yourself, is it identical to what I typed right here? No, I don't think it is. Do all the signs flip? Almost. The 2x flipped, the x flipped, but negative 1 is still negative 1. So no symmetry. All right, step 2, this should be a little bit more familiar with these remaining steps. We're going to find the y-intercept, and you do that by plugging in 0. And we get 0 up top. 0 minus 1, all that is just 0. So you make a dot on the origin, because that's a y-intercept at 0. For the x-intercept, I give you little hints up there next to the steps, because it's been a while since we did those 2. For x-intercept, I'm going to set the numerator equal to 0, and I just get 0 again. All right, moving to the new stuff. Vertical asymptotes. We just learned that yesterday. That's when you set the denominator equal to 0. If you can factor, we can't factor here, but I can solve that. It's just x equals 1. So on my graph, I'm going to make a dotted line up and down going through 1. Hopefully that stands out. Sometimes it's hard to see these when you're drawing over a black line. right, let's see, horizontal asymptote. I'm running out of room. This is where you look at the degree of the numerator and compare it to the degree of the denominator. In the numerator, I see a degree of 1 because there's really an exponent of 1 right there above the x. In the denominator, there's also a degree of 1 because there's really a 1 right there. And since n equals m, if you flip back 2 pages or watch the last video, that's scenario 2. So that means I now need to look at the lead coefficients. The lead coefficient up top is 2. On the bottom, it's a 1. That 1 isn't written. It's right here in front of the x. And you put them over each other, and that is your horizontal asymptote. So we have a line at 2, sideways line at 2. So make a dashed line there. All right, we're almost there. So for step 6, I make a big T-chart and plug in values. Now the key is, let me change colors so I can mark where I'm talking about. I need to plug in into the equation. I need to plug in x values over here to the left of that vertical line, and I need to plug in values to the right of that vertical line. It's up to you how many you plug in. You do need to plug in some and show it, but I will say the more you plug in, the more shape you're going to see. So I picked some numbers. I plugged in -2, -1, and 0.5. I picked 0.5 because I didn't know what was happening right here. And I felt like if I plug in 0.5, I'm going to see more. 1.5, just to the right of that dotted line. 2, 3, and 4. So get your calculator, and you just practice typing those in place of x in that typed equation over there. And I got 1 1/3. I got 1, -2, 6, 4, 3, and 2 2/3. And plot those points. So we have a dot there, a dot there, and a dot here. So now you can kind of see what the graph does. Let's see, on the other side of the dotted line, we have a dot right here, right next to it up at 6. One at 2, 4. 3, 3. And 2 2/3. So let me change colors. And our lines look something like this. And if you want, you can go to the calculator and check it, type it into the graph, see if you get the same thing. All right, let's try one more of these. I'm going to go a little faster. This video is already getting long. All right, step 1, plug in -x. And when I do that, since I have -x squared, I actually get the same exact function that I typed. Because -x times -x is x squared. So we have symmetry about the y-axis. All right, step 2 is y-intercept. I'm going to plug in 0. Up top, I get 0 again. On the bottom, I get 0 minus 4. That all just equals 0. So let's make a dot right on the origin. Step 3 is x-intercept. This is where you set the numerator equal to 0. So 3x squared equals 0, and sure enough, we get 0 again. And we already have a dot there. All right, step 4, vertical asymptotes. Remember, this is where you set the denominator equal to 0. If you can factor, factor, because it's nice to be able to see what crosses out. And when we factor it, we get this. And I do a quick glance up at the original equation, see if I can cross out x plus 2 or x minus 2. I can't, so I have 2 vertical asymptotes at these 2 spots. So on your graph, make a dotted line up and down through 2 and negative 2. All right, let's see horizontal asymptotes. This is where you compare the degrees of the numerator and denominator. So in this one, the numerator has a degree of 2, and the denominator also has a degree of 2. Since those are both equal, that's scenario 2. You look at these lead coefficients in the top and in the bottom. So I see a 3 up top, and I see a 1 on the bottom. That 1 is this one right here. Look at the typed thing up top. There's an imaginary 1 there. So you put those over each other, and you have your horizontal asymptote at 3. So make a dashed line going sideways at 3. This one's way different because we have 3 quadrants. We have a graph maybe over here, a graph in the middle, and a graph to the right. So I need to pick values to the left, in the middle, and to the right. So the values I picked, I didn't pick as many as the last graph. I picked -4, -3, -1, +1, and 3 and 4. Maybe take a minute and practice plugging those into the equation. See if you get the same. It's a little more difficult because you're squaring. I get 4, 5.4, -1, -1, 5.4, and 4. All right, let's plot those points and we'll be done. So -4, 4, -3, 5, 4, -1, -1, 1, -1, 3, 5, 4, and 4, 4. And let's make our graphs. You're hopefully getting an idea of the typical pattern of these graphs. And then this one's kind of a skinny parabola. And then feel free to go to the calculator and check it. See if you get the same thing. All right, that's it. See y'all later.